Hello everyone. Today let's see about cache memory. Why cache is used? As we know, CPU speed is in GHz and hard drive speed is in Mbps. It cannot match with the CPU speed. The dynamic RAM is also not as fast as the CPU. But DRAM is faster than hard disk drive. Somehow it can match with the CPU speed. If dual quad-core and octal-core processors ask for data, then our memory speed is not enough to serve. To solve this problem, cache is introduced. Cache is a static RAM. It is much faster than the main memory, that is DRAM. It is also much costlier than the main memory. It is placed between the processor and the main memory. It is placed very close to processor. The data or instructions frequently required by processor or supplied or recently used data are stored in the cache. Here in this diagram, between the processor and the cache, the transfer is in the form of words. A word is the smallest addressable unit in cache. Between the main memory and the cache, the transfer is in the form of blocks, and between the hard disk drive and main memory, it is pages. There are different levels of cache, level 1 cache or L1 cache. Second one is level 2 cache or L2 cache. And third one is level 3 cache or L3 cache. Level 1 cache. It is fastest among all caches. Size could be in the range of 2 KB to 64 KB. A small amount of memory is integrated inside the processor itself. All cores of processors will have L1 cache. As L1 cache is integrated inside the processor, L1 can operate at the same speed of the processor. L1 can be categorized into two parts: instruction cache and data cache. The instruction cache holds instructions required by the processor, and data cache holds data required by the processor. L2 cache. The size could be in the range of 256 KB to 512 KB. It could be a part of the processor, mostly placed outside the processor. Each core of the processor can have its own L2 cache, or a common L2 cache could be shared by all cores of the processors. It is connected with the processor with very high speed bus. It is slower than L1 cache but faster than L3 cache or main memory. Level 3 cache. It is a higher in architecture. It is placed outside the processor and shared among all the cores of processor. This will enhance the performance of L1 and L2 cache. Size could be in the range of 1 MB to 8 MB. It is slower than L2 cache but faster than main memory. There are different levels of cache. It can have single level cache and multi-level cache. Data access flow. The processor looks for the data in cache. If data is available in cache, it is called as the cache hit. The time taken to find out whether the data is available in cache is called as the hit latency. If the data is not available in cache, it is called as the cache miss. The number of data finds in to the number of attempts by the processor is the hit ratio. High hit ratio means high processor utilization. Hit ratio is equal to cache hit divided by number of requests of hit plus miss into 100%. The tag directory in the hash has the information whether the cache has the required data. Cache miss latency. Cache memory cannot hold all blocks of main memory. During this time, a cache miss is occurred. In case of cache miss, the processor looks for the data inside the main memory. The time taken for this process is called the cache miss latency. Between the cache and the main memory, the transfer is in the form of block. So, if the required data is not available in the main memory, it is called as the page fault. If the required data is available in the main memory, it is called as the page hit. If it get the data from the hard disk drive and load to the main memory, it is called as the page fault service. Or the OS searches in secondary memory, it is called as the page fault service. Between the main memory and the HDD, the transfer is in the form of page. The time taken to get the data is called as the page fault service. Principle behind cache memory. Cache memory is based on the property of computer programs known as the locality of reference. The analysis of program indicates that many instructions in localized areas of program are executed repeatedly during some time period than the remainder of the program. This is called as the locality of reference. There are two ways of locality of reference. Temporal locality of reference is based on time. Recently executed instruction is likely to be executed again very soon. Next one is spatial locality of reference. It is based on space. The instructions in close proximity to a recently executed instruction are likely to be executed soon. Replacement algorithm. When the cache is full and block of words need to be transferred from main memory, some blocks of words must be replaced. It is called as replacement algorithm. Cache memory mapping. The technique that defines how the contents of the main memory is brought into the cache is called as the cache memory mapping. There are three memory techniques: direct mapping, associate mapping, and set associate mapping. Direct mapping. A particular block of main memory can be brought into a particular block of cache memory. This is called as the direct mapping. Next one is associative mapping. In this mapping function, any block of main memory can potentially reside in any cache block position. It is a very flexible mapping method. Set associative mapping. In this method, blocks of cache are grouped into sets and the mapping allows a block of memory to reside in any block of a specific set. This is set associative mapping. Thank you for watching. Please like and subscribe for more videos.